Hello guys, Sawadee Cap. Teacher Romain here for another math lesson. And today I'm very excited because we're going to do something new for you guys, okay? In the last lessons, we reviewed some things from the last years, but now this is going to be new, okay? So this is the unit 1, and this is called the trigonometric ratios, okay? So maybe you don't know what that is yet, but don't worry, I will explain to you guys. But before I start explaining, I want to remind you about what we know. So if you watched my last video on Pythagoras, you know that in math we really love right triangles, right? And it's still going to be the same. We're still going to work with right triangles today, okay? So what did we learn about right triangles so far? So the right triangle is a triangle with a right angle, okay? A right angle is 90 degrees, all right? So right here, you can see there is a right angle, okay? And anytime you have a right angle, you need to give a name to the sides, right? And the first side you give a name to is the side opposite of the right angle, or the longest side, okay? This side is called the hypotenuse. So right here, if this is the right angle, the side opposite of the right angle is right here, right? This is BC or CB, and we give it the name the hypotenuse, okay? We saw that from the last video, right? The second thing we saw, after the hypotenuse, we need to find the adjacent side and the opposite side, okay? And to do that, we need to choose an angle, all right? There is the right angle, and then there are two more angles, all right? There is this angle here, the angle C, or the angle ACB, and the angle here, okay? Angle B or angle CBA, all right? So we're just going to choose an angle, and as usual I like the angle B, so I choose this angle and I call it theta, all right? And when we do this, we can find the opposite side of theta and the adjacent side of theta, all right? Remember guys, opposite means on the other side, okay? It means on the other side of the angle. So if theta is here, the opposite side is on the other side, okay, right here. So this is AC or CA. We say that AC is the opposite side of theta, okay? Now we just have to find the adjacent side. Adjacent side is the last side, so that would be AB if we already know the hypotenuse and the opposite side. But if you want to find the adjacent side first, adjacent, it means next to. Remember adjective in English, okay? Next to something. So angle theta has two sides adjacent to it, yeah? BC and AB or BA. But BC is already the hypotenuse, so the only side that doesn't have a name is AB, okay? So AB is the adjacent side, all right? So this is something you will always do every time you see a right triangle now, okay? Because we will need these names, okay? We need to find the hypotenuse, the adjacent side, and the opposite side. Okay, guys? I hope this is all good for everybody, okay? Alright, so you guys are now in Matheum 3, right? So you studied triangles for 2 years already. And in the first year, you learned that the sum of the angles in a triangle is 180 degrees. So if you know two angles, you can find the angle number 3 using one angle plus one angle plus one angle equals 180 degrees. Okay, this is from Matheum 1. In Matheum 2, you learn Pythagoras. Okay, this is what we review in the last video. Yeah, Pythagoras, c squared equals a squared plus b squared. Hypotenuse square equals adjacent side square plus opposite side square. Okay, so if you know two sides in a right triangle, you can use Pythagoras to find the side number 3. But now, if I ask you guys, I give you a triangle and I give you two angles and one side, do you think we can do something? Right? If we take this triangle here and I say to you guys, okay, this is a right triangle here, and this angle is 30 degrees, and this side here is 5 centimeters. And I will ask you maybe find the area of the triangle, or tell me how much are the other two sides, okay? And you're all very smart students, so you're going to look at this and you will see that here is a right angle, right? So you tell me, oh, okay, right angle is 90 degrees. So we know two angles, so we can find this angle here, right? You're going to say, oh, teacher, this angle easy to find, okay? Because this angle here plus this angle here plus this one should make 180 degrees, right? So we should have in this triangle 30 degrees plus 90 degrees plus something, okay? The angle number 3 should be equal to 180 degrees, okay? So how much is the missing angle? 30 plus 90 is 120 degrees. How much do we need to make it to 180 degrees? We need 60 degrees, right? They do. I'm sorry, excuse me. Up, okay. So doing this, okay, we can find that this angle here is 60 degrees. Okay, but my question is, I want to know how much is this side, or how much is this side, or how much is the area, okay? Okay, and now the other thing you can do in a right triangle is Pythagoras, right? Pythagoras, he says what? Pythagoras, he says that hypotenuse square equals opposite side square plus adjacent side square, right? Okay. So Pythagoras we can use when we know two sides and we want to find the side number 3. But here we know only one side. We know this side here is 5 centimeters, but we don't know this side, and we don't know this side, okay? We don't know the hypotenuse. So we cannot do Pythagoras because we know only one side, okay? So now this is the time where you look at me and you say, oh, teacher, may I don't know how to do, right? But actually there is something you can do, okay? And this is what we're going to see in this lesson. And the answer, of course, is yes, we can do something, okay? And we are going to use the trigonometric ratios, okay? So I put them here for you guys. So we have sine theta, cosine theta, tangent theta, cosec theta, sec theta, and cotan theta. They look very cute, right? I know you love them already. No, I'm joking. I know they look very scary. I know when students see them, they get a headache already. But I will try to make it easy for you guys, okay? And I will try my best to explain what do they mean, okay? These weird letters, okay? I know it looks like the language of the demon, but trust me, when you understand them and you know them, they're very, very nice, actually. They're very friendly, okay? And you can use them for a lot of things. Alright, but before I start to teach you about them, I would just want to warm up about what we know about triangles already, okay? About the angles, about Pythagoras, and what we can do in a triangle already, okay? And then I will show you why we need the trigonometric ratios to do more things. Alright, guys? Alright, guys, so before I continue with the lesson, I will tell you something. I tell you that in a right triangle, if we know one side and two angles, so the right angle and then another angle, we already know what the triangle looks like, okay? There can be only one triangle, okay? You guys believe me? Well, I hope you don't believe me, okay? You should not believe everything I say, but I will show you that what I say is right, okay? Then you can believe me 100%, all right? So, all right, need to warm up a little bit. I will do some drawing for you guys, all right? So we are going to build a right triangle, okay? So in a right triangle, we know what? The first thing we know is that there is a right angle, okay? In a right triangle, there is a right angle. That's why we call it like this, right? So I'm going to make a right angle. This is my right angle. Okay, good. Now what? I told you that I need to know one angle of the triangle. So I'm just going to make on the side here an angle. Okay, we're going to say that my triangle has an angle. So here I'm going to make an angle of 45 degrees, but well, it could be any angle. Okay, we have one angle. all right? And when we do this, actually, we already know a lot of things. We already know the angle number 3, right? Because the right angle plus this angle plus the other angle, together they should make 180 degrees, right? This is the first thing you learn about triangles. So here, if this angle is 90 degrees, this angle is 45 degrees, then the angle number 3 would be also 45 degrees. Okay, so actually now we know the 3 angles of the triangle. So we already know a lot of things. So now what I can do, I can take the two, the right angle and the angle, and put them together, and we'll see what happens. Okay, I take it here, and I'm gonna put it together. Try to close my triangle. Okay, when I do this, now my triangle is closed. So I have my right angle, my angle of 45 degrees, and then this angle, because the 3 together should be 180 degrees, this one is also 45. Okay, we have 45, 45, 90 degrees. This one cannot be different, all right? But now we can change a lot of things, okay? I can put it here, have a small triangle. I can put it here. I could put it there and have a bigger triangle, right? And that's where it gets really interesting, okay? Remember, I say we want to know one side, okay? So imagine we look at this side down here. So I can say, okay, I want this side to be 5 centimeters, 10 centimeters, 20. Okay, so this is the thing that I can change, and I can change it by putting my angle closer or further, right? So now maybe I say my side is 10 centimeters. Now it would be 15. If I could make it smaller, it would be 5 centimeters. All right. And what do you guys see when I do this? Okay, now if I put my angle here and I say my side is this long, I cannot change anything else, right? These two sides, they have to be like this. It cannot be different. Because of the angles, the sum has to be 180, so the angles have to be like this, and we already choose one side, so we cannot change anything else, okay? If I want my side to be longer, all the other sides are also longer, okay guys? But every time there can be only one triangle that looks like this, that has these two angles, the right angle and the angle that I choose, and then one side, okay? And now that's where actually it gets even more interesting, okay? Look at this, guys. All right, let's say I take my triangle like this. And what I'm going to do, I will make a copy of this triangle, okay? I want to keep it. So up, take it, put it here. Okay, this is my triangle. And then in the other triangle, I will change my angle, okay? I will change my side to make it, let's say, smaller, okay? I'm gonna take it, all right, like this, a really small and cute triangle, okay? All right, so I had to make it a little bit smaller to cut the sides to do what I want to do now. And look at this, guys. Now what I'm going to say is very, very important. These two triangles, actually, they are kind of the same. They are similar. We say that they have the same ratios. Okay, I would write for you the same ratios. Okay, or we can also say they have the same proportions. Maybe you know this was proportions. Okay, it means the same thing. What does it mean? It means that these two triangles, they are the same, but just they are bigger or smaller, but all the sides have the same proportions, the same ratios, okay? And I show you guys, if I take this small triangle here and I just make it bigger, okay? You guys know when I do this, I just increase the size, I make it bigger or smaller, okay? So I took the small triangle that I made, I'm going to make it bigger, and now what happens? If I try to put them together on top of each other, up so it's a little bit bigger, they are, yeah, okay, you see like this, they are the same triangle. All I had to do was take the small one and make everything bigger, and now we have the same triangle, okay? They have the same proportions, we say the same ratios. And that is the point of the lesson, guys, okay? In a triangle, if we know all the sides of a triangle, then we know the proportions, okay? That's what I showed you. If I know one side, then I know the other side because there's the right angle, the other side, and because the sum is 180 degrees, I know the three angles. And if I know the 3 angles, I know what my triangle looks like. Okay, I don't know how big it is, how small it is. To know that, I need to know one side, but if I know the angles, I know the proportions of my triangle. Okay, and then it's just about if my triangle is small or is big. Okay, and to get this information, then I will need to know one side. If I know one side, I know all the sides, because I know if my triangle is big or small. Okay, guys, I hope you understand that. So this is what you will learn in this lesson. Okay, I will teach you how to use the ratios in the triangle. Okay, this is what we call cosine, sine, and tangent, but actually it's just about the ratios. All right, every time we will use the ratio. If we know the angles in the triangle and we know one side, then we can know all the other sides of the triangle. Okay. Alright, so now before I teach you the trigonometric ratios, I need to make sure you know what is a ratio. Okay, this is something you learn in Platon, but maybe you forgot already. Alright, so I will explain to you again. So you get a ratio when you compare two of the same kind of things. Okay, in Platon, so you see this kind of ratio. This one is a ratio of 5 to 1. Okay, it means there is 5 of something and then 1 of something else. All right, so I made this example for you guys. Here there are 5 apples, 1 banana. So we say that the ratio of apples to banana is 5 to 1. There are 5 apples, 1 banana, so 5 to 1. All right, guys. Okay, now if I change it, I take 3 apples, 3 bananas, the ratio becomes 3 to 3. Okay, there are as many apples as bananas. So we say the ratio is 3 to 3. But another way to say it is that there is, for every banana, there is 1 apple. Okay, if I put it like this, there is 1 apple, 1 banana, 1 apple, 1 banana. And this ratio is the ratio 1 to 1. Okay, so the ratio 3 to 3 and 1 to 1 is the same thing. Okay, so you should know that already, but you can simplify the ratio. Okay, the ratio is like a division. 3 divided by 3 is same as 1 divided by 1. Okay, 5 divided by 5, any number divided by the same number. Okay, so ratio is like a division. Okay, so ratio, it's like a division. All right, we use the ratio to compare two things, and I even want to say two of the same kind of things. Okay, here we're comparing apples and bananas, so it's like comparing two fruits or two objects. Okay, you cannot compare like if you say there is 5 meters and 1 apple, you cannot make a ratio. It doesn't make sense. Okay, and if you compare I don't know, 5 seconds and 10 bananas, okay, when we make a ratio, we have to compare the same kind of things. Okay, this is going to be important for the trigonometry. But ratio, the idea of the ratio is very simple. Okay, if we know the ratio, we know what there is more of. Okay, one is more than the other. If there's 5 apples, 1 banana, the ratio is 5 to 1. So we know that there are more apples than bananas. Okay, the idea is very simple. This is also what we're going to use in trigonometry. Okay, we will have a ratio, and we will see that depending on the ratio, there will be more of something and less than something else. Okay. All right, cool. So now you know what is a ratio, and we want to use the ratio in a right triangle. Okay, so what can we compare in a right triangle? We know that a triangle is made of sides. There are 3 sides and 3 angles, and we know that to make a ratio, we need to compare the same kind of things. So we cannot compare an angle and a side. Okay, we have to compare all the sides together or the angles together, right? I'm sorry guys, but I will give you a spoiler. But the ratios we're going to use will compare the sides of the triangle. Okay, not the angles, but it will be the sides. We will make ratios with the sides of the triangle. Okay, I hope you guys remember this part of the video. Here I told you that when we know the angles of the triangle, actually we know the ratios, the proportions of the triangle. Okay, and then if we know one side, we know if the triangle is small or big. Okay, and this is where we link together the ratio that we're going to use. Okay, so it's going to work like this. Because we know the angles of the triangles, we know the ratios. And the ratios, I told you, we're going to divide the sides together. So to get a ratio, we divide two sides of the triangle together. Okay, we know the angles, we know the ratio. So we know that when we divide two sides of the triangle together, we get this ratio. And that's why I told you guys, then if we know one side, then we can find the other side. Okay, we have a division of two sides equal the ratio that we will know because we know the angles. And then if we know one of the two sides, we can find the other one. Okay, that's how it's going to work. All right. All right. So I think you guys are now ready to meet my friends. So I introduce you to sine, cosine, and tangent. Okay. So I didn't lie to you guys. These ratios, they are ratios because we divide two things together. Here we divide the two sides. Okay, so there are three ratios. It makes sense. Why? Because there are three sides in the triangle: the opposite side, the hypotenuse, and the adjacent side. So we can, if we want to make a ratio, we want to divide two sides. We can divide opposite side and hypotenuse, hypotenuse and adjacent side and opposite side. So no surprise, here we have three ratios. Okay. So each ratio has a special name. Okay, we have sine, cosine, and tangent. And you see here we have in the brackets theta. Theta is an angle. Okay. In the brackets we have to say theta, what angle we are looking at. Okay, remember guys, when I say the opposite side or the adjacent side, it depends on what angle theta I look at. Okay, so when I say a ratio, I use the opposite side and the adjacent side, so I have to say what angle theta I'm looking at. All right guys, that's why here we have the sine of this angle is this opposite side and the hypotenuse. Okay. So now this is where the students start to cry because there is a lot of things. It looks like there are a lot of things to learn. Okay, you have to learn that the sine of theta is opposite side divided by hypotenuse. The cosine of theta is the adjacent side divided by the hypotenuse. And the tangent theta is the opposite side divided by the adjacent side. So it looks like a lot, and I agree with you, it looks like a lot. But of course, there is always a way to remember, right? So to remember this, and it's also what I do, guys, okay? This is how I remember that it's like this. We use a magic word, okay? And the magic word, guys, is SOHCAHTOA, okay? SOHCAHTOA. You know what it means? It means absolutely nothing, okay? It's just a word that sounds funny and is easy to remember, okay? SOHCAHTOA, SOHCAHTOA, all right? I will try to repeat it a lot because I want to really put it deep in your brain because if you remember this, you don't have to learn a single thing, okay? I'll show you how we use SOHCAHTOA to remember, all right? Okay, so we know that there are three ratios, right? There is sine theta. Well, I cannot make a theta here, so I will make an A, okay? Sine A. There is cosine A, and there is tangent A. Tangent, sorry, A. Okay, there are the three trigonometric ratio that we have to remember, okay? Three ratios, three sides. The three sides are hypotenuse, okay, adjacent side, and opposite side. Okay, all right, that's what we need to remember, okay? And now I'm sure you're all super smart students and you notice that the letters of SOHCAHTOA is the first letter of the ratios and the sides, right? And that's how we use SOHCAHTOA, okay? You know that these ratios, because they are ratios, they are division of fractions, okay? So we need to divide two things all the times, okay? So sine, cosine, tangent, we divide something, okay? So they are equal to something that we divide. And what we divide is the sides of the triangle, right? Okay, so if you know that already, it's already super good, okay? And now if we look at SOHCAHTOA, we see that the first part is SO, okay, S-O-H. The meaning is sine, okay, sine SO is O, opposite side, over H, hypotenuse, okay? and bam, we just did it. Okay, don't need to remember a lot of things. We know, because we know SOHCAHTOA, we know that sine theta is opposite side over hypotenuse. Okay. Okay, now the second part of the word, ka. So C is for cosine, of course. A is the adjacent side. H is the hypotenuse. So cosine is the adjacent side over the hypotenuse. Okay, easy. And the last part, toa. So toa. T is for tangent. O, opposite side, and A, adjacent side. Okay, easy enough. And there you go. Okay, so it looks a bit messy. I'm sorry. I'm gonna try to make some room. So yeah, I really recommend that you try to remember this one, SOHCAHTOA. Okay. So for 2 weeks before you go to bed, you say in your head 50 times SOHCAHTOA. Okay, SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. Okay. Yeah, really, guys. For me, I'm really talking for me as a student. It helped me a lot, and it still helped me. You know, even today, I still remember SOHCAHTOA to remember what is the sine, what is the cosine, what is the tangent. Okay. If you don't know SOHCAHTOA, it's very easy to make a mistake. All right. All right, guys. So really try to remember SOHCAHTOA. All right. It tells you, it helps you to remember the ratios. All right. And then the second thing is that, okay, there are ratios. So remember the ratio. It helps you to know if there is more of something. Remember, like 5 apples, 1 banana. Okay. And the ratio is like a division. So when we divide the two sides, we divide the opposite side and the hypotenuse, and the value of the ratio. So how much is this ratio? It will tell you what side there is more of, or what side is longer. As simple as that. If the ratio is 1, it means that the opposite side is equal to the hypotenuse. Okay, so the ratio is 1. The two sides are the same length. If the ratio is 2, it means the opposite side is 2 times longer than the hypotenuse. Okay, and if you're a smart student, you should know that it's not possible, because the hypotenuse is the longest side, so the opposite side cannot be longer. Okay, so it will means that these ratios, the sine and the cosine, it cannot be more than 1 actually, but I will explain that later. Okay, the ratios, it could be like 0.5. Okay, if it's 0.5 or 1 over 2, it means that the hypotenuse is 2 times longer than the opposite side. Okay, that's how we will use the ratios. All right. Okay, guys, one last thing before this lesson is over, and I'm really sorry about it. I don't want to teach it because honestly, I don't like it and I think it's very useless. But so the three main ratios are sine, cosine, and tangent. But there are 3 more. Okay, I told you there is cosec, sec, and cotan. Okay, and you have to learn them because you have some exercises where you have to learn them. And I had to learn them too when I was a student. And honestly, I don't like it because it's not super easy to remember. It's easy to make a mistake. And also, I never used it anywhere else than an exercise. Okay, the sine, the cosine, the tangent, we use them a lot, especially in science. But the sec, the cosec, the cotan, I never use them. Okay, but I'm sorry, you have to learn them anyway. So here they are. So remember, guys, in the triangle there are 3 sides, so opposite, hypotenuse, adjacent. So sine, we divide the opposite side by the hypotenuse, but of course you could do the other ratio, divide the hypotenuse by the opposite side. Okay, and that's exactly what the reciprocal are. Okay, they are the same as the usual ratio from SOHCAHTOA, but the other way around. Okay, so if sine is opposite side over hypotenuse, cosec is hypotenuse over opposite side. Okay, or we write it like this: 1 over sine theta. Okay, we just take the fraction and switch the 2 words. Okay, guys, so it's the same for sec and cotan. And the reason why I don't like them so much is because if it's just 1 over, it's very easy to find them. Okay, we don't really need to give another name. 1 over sine is already very easy to find. Okay, that's why I don't really like to give another name. And especially you guys see that sec Sec is the reciprocal of cos, okay? Sec is 1 over cos. And cosec is 1 over sine, okay? It would be easy if cosec go with cos and sec go with sine. It would be easy to remember, but it's not like this, okay? And I used to make a lot of mistakes like this because I don't remember which one go with what, okay? So I don't know, guys. Remember that you have to switch, okay? That it's not normal, okay? That you have to do the other way. Cosec is 1 over sine, sec is 1 over cos, all right? I'm sorry about this, I didn't decide it. Well, good luck with that. And yeah, cotan is easy. The cotan is 1 over tan, okay? Tangent, toa, SOHCAHTOA, toa is O over A, cotan is A over O, okay? So yeah, you will just see them in the exercises. You guys, I really want you guys to remember just sine, cosine, tangent. Okay, they are the most important. Really, we use them in a lot of other areas than mathematics. In science, you ask teacher Dana if you don't believe me. We use them a lot. Okay, when we do physics, when we do chemistry, it's really important to know how to use them. Okay, but cosec, sec, and cotan, you will see them only in math exercises. Okay, guys? Okay, guys, so that's all for this lesson. I really hope that you understand what are the ratios, okay, what they mean about the triangles, okay, that when we know the angles of the triangle, then we know what the triangle looks like, and then with the sides, we know if the triangle is big or small, okay, but when we know the angles, we will be able to find the ratios between the sides, okay, that's how we will use the ratios, but I will show you guys in the next videos. For now, I want you to remember SOHCAHTOA, okay, so how to use it to find the formulas, the ratios, okay, sine, so sine is O over H, K, C is A over H, and TOA, T is O over A, okay, and try to remember the reciprocals if you can. And yeah, I really want to try to make you understand the meaning of these ratios, okay? Because when I'm a student, my teacher don't teach me like this, okay? I just have to learn everything, but I don't understand what they mean, okay? It's just later that I learned by myself the meaning of the ratios, and it makes more sense when you understand. You will understand why the ratio cannot be more than 1 because, okay, we divide by the hypotenuse and hypotenuse is the longest side, so it can never be more than 1. Okay, so a lot of small things, if you understand what I try to explain to you, it will make sense. Okay, guys? But I hope you can let me know about that in the feedback of the video. Okay, if you have any questions, ask me in the feedback, in the comments of the video, in the classroom, anywhere. Yeah, I'd like to remind you guys that this is the first time that I make videos. So it's very different because you're not in front of me. So I'm never sure if you understand what I say or if you don't. Okay. And yeah, I want to try to make my videos better and easy to understand. Okay. I try to make a lot of drawings. I try to repeat the same things a lot of times. And that's why my videos are very long and it takes me a long time to make. Okay. So yeah, I also need your help to make these videos better, okay? To let me know what you think about the videos, how I can make them better, okay? Remember, I make these videos for you guys. I'm trying my best, so I also expect that you do your best too, okay? And you help me to make it better, all right? All right. Anyway, I hope you're excited about this lesson. So it's very exciting for me too because it's something new. I always like to teach something new. It's a bit boring when I have to teach you something that you already know. So this should be new. So yeah, I hope you guys enjoyed the video. In the meantime, stay safe, take care, and I will see you in the next video. Do your best.